Hello children, welcome to Topper IIT Foundation. So in this session I am going to teach you about the property of rational number from 8th class. Okay, so first we will discuss about the operations of addition. So addition of rational numbers. Okay, addition of rational numbers. In that the properties of rational numbers under addition. So the first one is closure property. Second one is commutative property. Third one is associative property. Next, another one is additive identity. Okay children, so these we will discuss one by one. Okay, so first we will discuss about closure property. Do you know children what is the mean by closure property? Okay, so here definition of closure property is under addition. The definition of closure property under addition is, for example, if A comma B C are, what are they? Three rational numbers. Rational numbers. If A plus B plus C, okay, here A also a rational number and B also a rational number and C also a rational number, then we can say the rational numbers are satisfy the closure property under addition. So when we have to say the rational numbers satisfy the closure property under addition, sum of two rational numbers also a rational number, then we can say the rational numbers are satisfy the closure property under addition. The sum of two rational numbers also a rational number, then the rational numbers are satisfy the closure property under addition. For example, so 1 by 2 plus 2 by 3. So assume this as a and this is a B. So it is in the form of B by 2. Means it is a rational number. It is also in the form of B by 2. So it is also a rational number. Then we can add these two numbers. So children, already I said to you, when we add two rational number, okay, first we have to equate the denominator. So how can we equate the denominator? By finding the Lcm of denominators. So what are the denominators here? So 2, 3 are the denominators. What is the LCM of 2, 3? LCM of 2, 3 is 6. LCM of 2, 3 is 6. So now, we can take the LCM equal to 6. Here 1 into, in this 2 table, when we will get 6? So 3s are. So that's why this numerator we should multiply with 3. Next, here this 2 as is right, and in this 3 denominator one, see, in this 3 table when we will get 6? 2s are. So that's why we will get 2 into 2. Next, 1 3s are 3 plus 2 2s are 4 by 6, that equal to 7 by 6. Now see children, this 7 by 6 in the form of P by Q, then what can we say? It is a rational number. And see, the sum of two rational numbers also a rational number. Then the rational numbers are satisfy the closure property under addition. Did you understand children? Okay. Next we will discuss about commutative property under addition. Next we will discuss about commutative property. Commutative property under addition. So what is the mean by commutative property, children? So commutative property nothing but if a comma b are two rational numbers, a comma b are two rational numbers, and if of a plus b equal to b plus a plus b equal to b plus a, then we can say the rational numbers are satisfy the which one? Commutative property under addition. If a comma b are two rational numbers, if a comma b are two rational numbers, and if a plus b equal to b plus a, then the rational numbers are satisfy the commutative property under addition. So simply we take some examples, few examples. Okay. So for example, previous case we assumed that as a equal to 1 by 2 as well as b equal to 2 by 3. Okay. Here b equal to 2 by 3 and a equal to 1 by 2. So once again see children, so when we are going to add two rational numbers, first the denominator should be equal. After then we have to add the which one? Numerator. So once check the children, here the denominator unequal. The denominators are unequal. So then what we have to do? We can find the LCM of denominators. So what is the LCM of 2 and 3? 6. Okay. Then so here 1 into in 2 table when will you get 6? 3 is plus 2 into in 3 table when will you get 2? Means 6. 3 table 3 to the 6. So multiply with 2. Same way, and LCM of 3 and 2. LCM of 3 and 2 equal to 6. Again here denominator one see 3. So in 3 table when you will get 6? 2 the. So this one multiply with 2 plus here denominator one see 2. In 2 table when will you get 6? 3 the. So 1 into 3. So now 1 into 3 3 and 2 into 2 4 by 6. 2 into 2 4 1 into 3 3 by 6. So that equal to 7 by 6 and 7 by 6. Just observe children here LHS equal to RHS. What is the given condition is a plus b equal to b plus a. So now we got these two are equal. Then what can we say? The rational numbers are satisfying the commutative property under addition. So this is the example for commutative property under addition. Commutative property under addition of a rational number. Okay. So next we will discuss about associative property of rational numbers under addition. Associative property of rational numbers under addition. So for example, one see associative property. Okay. So if a plus b plus c means here first we have to add second term and third term, then first term equal to first here we add first term and second term, then third term. Okay. So this is called as associative property. Here if a, b and c are three rational numbers. Okay. If the numbers satisfy the condition of the given, means the sum of second term and third term, then first term, and your sum of first term and second term, then third term are equal, then we can say the rational numbers are satisfy the property? Associative property under addition. Okay, so here simply we can take a few examples for this one. So assume that as a equal to 1 by 2 and B equal to 2 by 3 and C equal to 1 by 5. Okay, here also substitute the value 1 by 2, 2 by 3 as well as 1 by 5. Okay, so now one see, according to the Bodmas rules, which one we have to simplify first? Brackets. Okay, so in left hand side we should simplify first this bracket, then after right hand side this bracket. So when we are going to add, check children whether the denominators are equal or not. Okay, so in case if the denominators are not equal, what can we do? We have to find the LCM of the denominators. Okay, so here just simplify the numbers of the operation in the bracket. So the LCM of 3 and 5 equal to 15. Okay, so here one see children, here numerator is 2 and denominator is 3. In 3 table when will you get 15? 5. So write 5 plus, here numerator is 1, denominator is 5. Okay, in 5 table when will you get 15? 3. So write 3 equal to, here again we have to simplify this bracket first children. So what is the LCM of 2 and 3? 6. Because we should not add the fraction as a like. Okay, what we have to do? First we equate the denominator. After equating the denominator, we can add the numerators. Only if it is or if they are like fraction, then only we have to add. So what is the mean by like fraction children? If the denominators of fractions are same, then such type of fractions are known as which one? Like fractions. Okay, so here the LCM of 2 and 3 equal to 6 and your numerator is 1, denominator is 2. So in 2 table when will you get 6? 3. So multiply numerator with 3, again write plus. So your numerator is 2 and the denominator is 3. In 3 table when will you get 6 children? 2. So multiply numerator with 2 and plus 1 by 5, write as 6. Okay, so then you multiply the terms which are in the bracket, write 1 by 2, 2 5s are 10, 1 3s are 3 by 15 equal to 1 3s are 3 plus 2 2s are 4 by 6 plus 1 by 5. So your 1 by 2 plus 13 by 15 equal to 7 by 6 plus 1 by 5. So now bracket completed children. So then again we have to add these two fractions. Before adding, check whether the two fractions have same denominators or not. In case if they don't have same denominator, what we have to do children? Find the LCM of denominators. So here LCM of 2 and 15 is 30. Okay, so your 1 is the numerator, 2 is the denominator. So in 2 table when will you get 30? 15 plus 13 into your denominator 1 see 15. In 15 table when will you get 30? 2. So multiply with 2. Same way here find the LCM of 6 and 5, because unlike we should not add as a like we should not add the fraction. After equating the denominators of fraction, then we have to add the numerators. So here the LCM of 6 and 5 equal to 30. Your 7 is the numerator, 6 is the denominator. In 6 table when will you get 30? 6 5s are. So multiply numerator with 5. Next 1 is the numerator, 5 is the denominator. So in 5th table or 5 table when will you get 30? 5 6 are. So write 6. Okay, then 1 into 15 15 and 13 into 2 is 26 by 30 equal to 7 into 5 35 plus 6 by 30. So 15 plus 26 equal to 41 by 30 and 35 plus 6 equal to 41 by 30. Once see children, your LHS equal to RHS. So finally what we got? A plus B plus C equal to A plus B of plus C. You understand? So if A, comma B and C are three rational numbers, and if they satisfy this condition, what is the condition? The sum of second and third term, then the sum of first term equal to sum of first term and second term, then third term, then we can say the rational numbers are satisfy associative property under addition. Did you understand children? So is it possible or not? Possible. So that's why what can we say? The rational numbers are satisfy the which property? Associative property under addition. So this is about associative property of rational numbers under addition. Okay children? Then we'll discuss about the additive identity. So, do you know children what is the mean by additive identity? So for example, A is a rational number. So here we are going to discuss about additive identity. Okay. So A is a rational number, and if we add 0 to the A, okay, it gives A. Or if we add A to the 0 or 0 to the A, it gives A only. Means if we add any number to the 0, okay, it gives the same number, then that property we call it as additive identity. So for example, 2 is a rational number. If we add 0 to the 2, okay, so it gives 2. So here what can we write the additive identity? So here 0 is the additive identity of 2. Means which number gives the sum of a rational number and itself is the rational number, then we can say that number is additive identity of the rational number. So here only one number is possible to give the same number when we add the number to the any rational number 0. Only 0 gives same number. When we add 0 with any rational number, it gives same rational number. So that's why what we call it as 0 is called as additive identity. 0 is called as additive identity. So not only 2, you can take any numbers. Any number if you add with 0, it gives the same number. So that's why we call it as 0 is additive identity. 0 is additive identity. So this is about additive identity children. So next we will discuss about the operations or properties on subtraction. Okay, properties on subtraction. Okay, same properties children generally we check which are satisfying or not. So now we are going to discuss about subtraction of which one? Rational numbers. Subtraction of rational numbers. Then after we can find out the closure property, commutative property, associative property and additive inverse also. Okay. So here one see the closure property under subtraction. closure property under subtraction. So what is the mean by closure property under subtraction? For example, if a comma b are two rational numbers and the subtraction of a and b equal to c, also a rational number. For example, a is a rational number and b also a rational number, c also a rational number. The differences of two rational number is also a rational number. Then we can say the rational numbers are satisfy the closure property under subtraction. Okay, so for example, if we take any number instead of a as well as b, the resultant is rational or other, we can check. Okay, so here once check the denominator, children. The denominators are not equal. If the denominators are not equal, what can we do? Find the LCM of denominators. Okay, so LCM of these two denominators equal to 6. Okay, then check the numerator. Here the numerator is 1 and the denominator is 2. In 2 table when will you get 6? 2 3s are. So multiply this number with 3. Okay, again here check the numerator is 2 and the denominator is 3. So in 3 table when will you get 6? 3 2s are. So that's why multiply numerator with 2. Okay, now 1 3s are 3 and 2 2s are 4 by 6, that equal to minus 1 by 6. Okay, so now see children, here 1 by 2 we assume that as a equal to 1 by 2 is a rational number and 2 by 3 also a rational number, and the resultant minus 1 by 6 also a rational number. So that's why the differences of two rational numbers also a rational number. So that's why what can we conclude it is the closure property of rational number means the rational numbers are satisfy the closure property under subtraction, because the input values what we took instead of a and b 1 by 2 and 2 by 3 and their subtraction gives minus 1 by 6. So here 1 by 2 is a rational number, 2 by 3 also a rational number, minus 1 by 6 also rational number. That's why what can we conclude? The rational numbers are satisfy the closure property under subtraction. Okay children, so next property under subtraction is commutative property. What is that children? Commutative property. Commutative property under subtraction. Same what we discussed in commutative property under addition. So instead of plus, here we have to use minus. So for example, a minus b equal to b minus a. A minus b equal to b minus a. For example, a and b are two rational numbers, and if they satisfy the condition a minus b equal to b minus a, a minus b equal to b minus a, then we can conclude that these rational numbers are satisfy the commutative property under subtraction. Is it possible? Then we check children. If it is equal, we can conclude that rational numbers are satisfy the commutative property under subtraction. Otherwise, what can we conclude? Rational numbers are not satisfy the commutative property under subtraction. Okay children, so same numbers we can take for this example. A equal to 1 by 2 and b equal to 2 by 3. So here same substitute to 2 by 3 minus 1 by 2. Again check children, here the denominators are unequal. So what can we do? Find the LCM of denominators. What is the LCM of 2 and 3? 6. Okay, once check the denominator here. 2 in 2 table, when will you get 6? 3s are. So multiply 1 with 3 and here check the numerator is 2 and the denominator is 3. When you get 6 in 3 table, okay, 3 2s are. So multiply this one with 2. So next comes to right hand side of the equation. Here again subtraction and there are unequal denominators. If denominators are not equal, what can we do? Find the LCM of denominators. What is the LCM of denominators? 6. What is the LCM of denominator? 6. Okay. Then check the numerator. Here denominator is 3. In 3 table, when will you get 6? 2s are. So multiply this one with 2 and your numerator is 1. Denominator is 2. In 2 table, when will you get 6? 3s are. So multiply numerator with 3. Okay. 1 3 is 3. Minus 2 2 is 4. By 6 equal to 2 2 is 4 minus 3 by 6. 3 minus 4 minus 1 by 6. 4 minus 3 1 by 6. Once see children, left hand side is minus 1 by 6. Right hand side is plus 1 by 6. Are they equal children? No. These are unequal. So now what can we conclude? The rational numbers are not satisfied. Commutative property. Not satisfied. Commutative property under subtraction. Under addition possible. Under addition it is satisfied, but under subtraction it is not satisfied. Remember children. So next we will discuss about associative property. Associative property under subtraction. Okay. So associative property under subtraction. So here see children, if A, B and C are two rational numbers and if they satisfy the condition A minus of B minus C equal to A minus B of minus C, means here first we can subtract C from B, then these two we subtract from A. Okay, next here we subtract B from A, next C we subtract from the resultant of A minus B. So then if LHS equal to RHS, we can conclude that the rational numbers are satisfy the associative property under subtraction. Okay, so here same example we can take 1 by 2, 2 by 3 as well as 1 by 5. So here 1 by 2, okay, and 2 by 3 and 1 by 5. So here one see children, according to the board mass rules, what we have to simplify? First we have to simplify brackets, then check the denominators of the numbers which are in the bracket. If they are equal denominator, you can subtract the numerators. But if they are unequal, what can we do? Find the LCM of denominators. So here 1 by 2 minus, what is the LCM of 3 and 5? 15. Okay. So now here numerator is 2, denominator is 3. In 3 table, when will you get 15? 5. So multiply numerator with 5. Next here numerator is 1, denominator is 5. In 5 table, when will you get 15? 3 are. Okay. So then here again check the denominator, unequal, find the LCM, 6. Okay. Then 1 is numerator, 1 is numerator and the denominator is 2. So then 2 table when will you get 6? 3 is the multiply numerator with 3 and here numerator is 2 and denominator is 3. Denominator is 3. So in 3 table when will you get 6? 2 the minus 1 by 5. Write as is. Okay. So then 1 by 2 minus 2 5 the 10 minus 1 3 the 3 by 15 equal to 1 3 the 3 minus 4 by 6 minus 1 by 5. Okay. So now 1 by 2 minus 10 minus 3 equal to 7 by 15 equal to 3 minus 4 that equal to what is that? Minus 1 by 6 minus 1 by 5. Again check the denominator, unequal, same process. LCM is 30. So here multiply this one with 15, it is multiply with 14. Next here LCM is 30. This one multiply with 5 and this one multiply with 6. So 15 minus 14 equal to 1 by 30 and minus 5 minus 6 equal to minus 11 by 30. Once see children, LHS is 1 by 30 but RHS is minus 11 by 30. Are they equal? No, that are not equal. So what can we conclude? The rational numbers are not satisfying associative property under subtraction. Okay children, did you understand?